fine. Okay, now I am just doing this one, server area. Take the area space now. Okay, from here, then here, up to, let me take it up here now. This is a floor area. Click enter. Let's say it is coming 30 something now, once again. So from here, okay, this small projections you can avoid, no problem. Then from here up to here, enter. We're getting 17.12. 17.12 meter square. So let me take it. So close it. Duplicate. There is a serving area. 17.12. Okay. And now serving area. Ceiling height, we are having false ceiling there, 2.7, 3.9. Yeah. So just 2.7 will be fine there. And dining, we have considered 3.9. Fine. So now, yeah, ventilation, food preparation, if you are having, you can consider cafeteria, fast food, kitchen, cooking. This one you can select. It is not exactly cooking area, but even though heat generation will be slightly more there, so I'll be selecting a slightly higher. Okay, this one. Internal data, lighting load, number of people just 2 only. Keep it there like medium work, no problem. 13.1 lighting load, 13.1, and wattage, equipment load, that we can keep there. Equipment load, sensible 500, latent 1000. There is no other load we are having. Okay, walls, windows and doors. Let me select. We are having 2 exposure, this side and this side. Okay, so I'll be taking from here to here, take the full exposure. Okay, from here 6.92 into 3.9. Okay, 26.98. Let's say 27 meters square. So that is west side only, 27 meters square. Any window? Nothing. So the remaining this area, so you can take from the full outer. When we are taking the exposure full outer, you have to take 2.66. Let's say 2.66 into 3.7, 9.84 meters square in south side. 9.84. South side it is 9.84. We need a window 1 there, because this one we have to consider as a window. Conduction, convection, radiation, everything should come there. 2.195. So 2.2 meter, let's say. So window, create a new window. South glass wall 2. 2.19, 2.2. Width 2.2, height 3.9. This is 4.8 only. This one is 0.8. Okay, there is no other exposure. Remaining things are coming inside only. All these are partition. Kitchen is air conditioned only. There is no partition as well in this side. And it's a fit out work. I guess fresh air, few fresh air is existing somewhere here. A fresh air duct is existing. A stub out is there. In ventilation, we can discuss. Roof and skylight, it is horizontal. 17.1. Okay, 17.1. Infiltration, no, it is pressurized space only. So 0, 0. Floor, slab floor on grade. Partition, nil, 0. Okay. Now we can create a system for both. So now we can generate the report. Individual report for dining area and serving area we can make, or the combined one. Anyhow, I'll be combining it. If it is mandatory, later I will be generating the separate report. You can go to the systems. Okay, so let me select a new default system. So it's a dining plus serving area. You can keep that as undefined, even that is also fine. Otherwise, I'll be taking terminal units, 2-pipe fan coil. Just add dining area and serving area. Within thermostat, the same 24-hour schedule you can assign, and nothing for common data. Fine. We can go to the sizing. Okay. Cooling sensible 10%, slightly if you are considering like a 15%, because few cooking activities will not happen in the serving area, even though sensible heat might be slightly high in some, not only sensible heat, and latent heat also sometimes high, since we are having meals and all. No? So slightly higher sensible, like 15%, cooling latent 10%, I'll be considering, heating 5%. Fine. So slightly higher safety factors I have considered. Click OK. So we can generate it. Right click, print and view design result, review. So we'll be getting the total coil load of 44.9 kilowatt of total coil load, and 2310 liter per second of airflow rate. Okay, fine. So all the three spaces, we did the heating and cooling load calculation. Now we have to generate a report for that schedule, and this is called a specified data. Now we have to select the equipment from the technical data sheet. Okay. So anyhow, the data that we have created in the last session we can open. I'll be creating a schedule for that. Okay, so we are having three spaces, and for example, hot kitchen, dining, and serving area. And how much total coil load we are having in kilowatt? We are having the total coil load of dining area, serving area together only. I'll be taking 44.92310. 44.92310 liter per second. Okay. So be merging it, 44.9 kilowatt. And see, I'm just going to select the machine from a technical data sheet. In this technical data sheet, the airflow rate they have provided in CFM, total coil load they have provided in mega BT per hour. In the detailed selection with respect to the evaporator entering and DBT, WBT condition, they have given in last pages. There they have provided the capacity in BT per hour. So we have to convert that in BT per hour, kilowatt. Okay, let me convert this in. I have taken in total coil load only, in kilowatt only. So the next one, the total coil load in ton of refrigeration. So total coil load in ton of refrigeration, merge it, format painter. Okay, keep it. The next total coil load in BTU per hour, and after that total coil load in mega BT per hour, MBH. Okay, fine. So total coil load in kilowatt divided by 3.516, we can convert that into ton of refrigeration. So ton of refrigeration multiplied by 12,000, you can convert that in BT per hour. Okay. And total coil load in ton of refrigeration into 12, you can convert that into mega BT per hour, or BT per hour divided by 1000, you can convert into mega BT per hour. So that is 153 MBH. Fine. Now we need airflow rate in liter per second. So for dining plus serving area together, we go to 2310 liter per second. Okay. So 2310 liter per second. So airflow rate in CFM This is in liter per second. We need that in cubic feet per minute. That will be a liter per second. Okay, multiplied by 2.11 or 2.119 precisely. This much CFM will come. Okay, now we need like a coil entering evaporator, entering DBT, and entering WBT. Those data we need to select the equipment from the technical data sheet from this catalog or technical data sheet. So that will be coil entering 27.8 and 19.3. 27.8 and 19.3. 27.8 and 19.3. Correct. 27.8, 19.3. That is in degrees centigrade. Okay, so this will be in degrees Celsius. Okay, so now we need to select the equipment. Meantime, hot kitchen also we can take. So hot kitchen we have already taken in the last session. Print and view design result review. That will come how much? 13.5 kilowatt of total coil load, 680 liter per second. So 13.5, 680. That is 13.5. Airflow rate is 680. The same you can once again. Total coil load divided by 3.516. You can convert that into ton of refrigeration. Ton of refrigeration multiplied by 12,000. We can. That is BT per hour. BT per hour divided by 1000. You can convert into ton of refrigeration to 12 or BT per hour divided by 1000. That is MBH. Airflow rate, that is fine. Liter per second into 2.119, you can convert into CFM. Entering DBT, WBT condition 25.9, 17.1. 25.9, 17.1. Okay. So these are our specified data. Means the design data. So this is called a specified data. What we have designed. Okay. Now the proposed data, we need to select the equipment. Okay, when you are making the tender drawings within the consulting firm, as a consultant, you can use this data to make the tender drawing. But as I told, we will be making the shop drawing only. We have to construct it. Correct. Shop drawing only I'll be making. By the help of this specified data, now we have to select the equipment from the technical data sheet. Heating and cooling load calculation using HAP software session, we have studied this. What all parameters that you require to select the AC machine by the help of a technical data sheet? Correct. Condenser entering temperature and entering WBT, entering DBT, total coil load, then airflow rate. We have already discussed that. So the same procedure I am going to do, but the catalog that I am going to use will be different. See, this one we have received from the this technical data sheet received. It's a Colex make. We have received from the supplier. And we are going to propose a ductable split AC. Okay, the refrigerant will be R410A. You know, that is most of the equipments nowadays we are using the same only. This is model number. CHCF is outdoor unit, means CHCF is concealed high efficiency condenser outdoor, and CHEF is concealed high efficiency evaporator. So CHCF and CHEF is the condenser evaporator code only. 030, this 30 is representing the capacity in mega BT per hour. 18 MBH, 24 MBH, 18 MBH is 1.5 ton, 24 is 2 ton, 36 is 3 ton, 48 is 4 ton, correct. And A, that is series number only, A series, B series and C series by manufacturer. Code number 2, A2 means 2 is 3 phase, 7 is single phase. Okay, these are the data. We can select, but this is a general time only. And the rating condition indoor temperature 26.7, but we have designed with the 24 only. And this data unit rating summary, this is for maximum airflow rate only. But we need to find the model either in medium speed or high speed. Kitchen area, we can go for high speed because sound is not a big issue there. Within the hot kitchen area, we can go for high speed option. And means there here, no? Within this area, we can go for high speed option since the sound is not a concern. But in front area, the NC value should be minimum. No, so sound should be minimum. So I'll be selecting medium speed option in this area, dining area and serving area. Okay. Fine. Anyhow, these are the model CHCF 18, 24, 30, 36, 42, 48 and 60. First we can select hot kitchen. Just go down. Our selection will be with respect to 46 degrees Celsius atmospheric condition. Ambient should be 46 degrees Celsius because for Abu Dhabi and all we will be selecting with respect to this only. Okay. Anyhow, what is MB? Here the capacity is in BT per hour. Hot kitchen, our requirement is how much? Hot kitchen, we need 46,075 BT per hour. 46. This is 15, 20. Okay, 46 means nearly. It will come nearly 48 somewhere here now. In this model, you have to select, or here we can check 48. CHCF 048. This 048 is representing the mega BT per hour. Mega BT per hour into 1000 BT per hour. So this data with respect to the BT per hour only. Okay, and so we need 46,000 BT per hour. Exactly the same we are not going to get. Plus or minus 10% is fine there. So the right model we can select. Anyhow, three options they have provided. Here you can see the condenser entering temperature, condenser ambient temperature, 95 degree Fahrenheit, 115 Fahrenheit. So which one we have to select? 115 only. For example, you can convert that. I'm going to convert a degree Celsius to degree Fahrenheit. For example, degree Celsius, let's say 46. Now I need to convert into degree Fahrenheit. Okay, means like this is equal to degree Celsius, okay, into 9/5 plus 32. Okay, you can convert into degree Fahrenheit. So okay, degree Celsius. So this is into 9/5. Celsius into 9/5. So that will come 114.8. Let's say that is 115. Okay, so 46 degree Celsius is equal to 114.8 degree Fahrenheit, or you can use Google as well. Okay, so like degree Fahrenheit, degree Celsius is 46. It will come 114.8. No, so that is easy. Fine. So that should be the selection 115. So in 115, this one, I need to select this. So this is, see, this is a total capacity in BT per hour. Okay, this is sensible capacity. I need total capacity only. So the total capacity we will be selecting from this table. Scroll down. Okay, so this is a total capacity table. Correct, this one. Three options. 1291. This is airflow rate only. This is airflow rate in CFM, cubic feet per minute. And this is a model number. So CHCF means condenser outdoor unit. This is A2. A2 means that is three phase. CHCF is evaporator indoor unit. Indoor unit, it is ductable unit only, no? So A7. A7 means that is single phase only, the connection. Normally, indoor equipment, ductable unit that is coming on inside will be having a fan only. So it will not be having the complex electrical equipment. So most of the time that will come like less than 500 watts only. So means single phase only it will come. Okay, so this is medium speed and this is high speed. Anyhow, hot kitchen, sound is not a problem. So that's why if you are designing comfort air conditioning areas like classroom, library, prayer room, the sound will be very less. Then you can go for low speed. Rest all the areas medium speed. Hot kitchen sound is not a big issue. So that's why I'll be going for high speed. Here we are having two options. This is entering, coil entering DBT and WBT only. Correct. Here you can see the first column we are having airflow rate in CFM. The second column, air on evaporator means on coil only. On what temperature the air is entering into the cooling coil or the evaporator coil. dB, this is dry bulb temperature and this is wet bulb temperature in Fahrenheit, but we need that in degree centigrade. We did that in degree centigrade only, so we have to convert that. So nearest value we can take. So 1426, this is the medium speed. Okay. So our requirement, coil entering condition, coil entering condition for hot kitchen is 25.9. So 25.9 degrees Celsius is nearly coil entering. DBT is coming 78.62 degree Fahrenheit. WBT is 17.1. 17.1. That will come like WBT 62.78, let's say 63 degree Fahrenheit. Okay. Both the values should match 84.66. 78.63. 78 is not there. Which one is near? Comparing to 78, 84 is near. Not 84, 80 is near. This one you can select. Correct. DBT 78.62, 74, 84 or 80. Which one is near? 80 only. 63, 62 is there. 67 is there, but unfortunately, if we are selecting this one, then the DBT will be too far away. So this one you can select for your reference, because both the value exactly it will not match in the real scenario. So this one you can select. Okay. So this is the total coil load, 48.415. Sorry, means 48.415 megabtu per hour, or 48,415 BTU per hour. So our requirement was 46, but we will not get that much, right? Okay. Now, what is the selection? Total coil load. Let me select total coil load in BT per hour now. How much we are getting? 48,415. 48,415. BT per hour is 48,415. Airflow rate we are getting in CFM only 1426 CFM. 1426 CFM. Whether that will match 1426 CFM? 1426 CFM. We need how much CFM? 680, right? Our airflow rate is 680. But here we are getting 1426. So 1426 CFM divided by 2.119, you can find that is in liter per second. 672. Okay, fine. We need 680, but the selection is 672. Plus or minus 10% allowance is fine there. Like that only we will get. Sometimes this way also we will not get. Okay, no problem. So airflow rate is also matching 1426 CFM. 1426 CFM. Okay, now we need the model number. Model, let's say CHCF 048A2. CHCF 048A2. This is condenser unit is 3-phase. Now CHEF 048A7. Correct. CHEF 048A7 single phase unit. Okay, so that was the selection. Now the total coil load, and if you want to convert, you can. Means like a ton of refrigeration means BTU per hour divided by 12,000. You can convert that into ton of refrigeration, single unit. Total coil load means ton of refrigeration into 3.516. Okay. Megabtu per hour is BTU per hour divided by 1000. That is megabtu per hour. Airflow rate in liter per second is CFM divided by 2.119. This much. This is called proposed data. Based on this only we will be making our shop drawings. Okay. It's called proposed data. The same way, dining and serving area we need to select. Anyhow, let me try, because we need to match with this model. There is no other option. Because client insisted to use this one. They told. Front area, no. How much we are getting? See, in dining and serving area together we are getting 12 ton, 12.7 ton. Anyhow, 12.7 ton means like more than 6 ton, 2 equipments you have to propose. But normally a ductable unit, single unit will come less than or equal to 5 ton of refrigeration only. But some make Panasonic and all, the ductable unit can come up to 8 ton options are also there. AHU, mini AHU will be available. Okay, anyhow, that much space we are not having above the false ceiling. 1.2 meter only we are having here. Okay, anyhow, so that's why 4 ton 3 equipments you can propose. Anyhow, minimum 2 equipment is not possible because single equipment, the maximum capacity, most of the manufacturer, it will come 5 ton only. So 2 equipment will come 10 ton, but our requirement is 12 or 12.7. So definitely 3 equipment, if it should match with the supplier. Let me check it. What options we will be having? Suppose in case if I am providing this 1,53,242 BTU per hour by the help of 3 equipment, what is the capacity of single equipment then? Okay, 2 ways we can try. The first option, what is the maximum capacity of this model? Okay, this is the last selection sheet. The maximum capacity of this model, see, as I told, dining area, front area, no? Dining area and serving area, I will not be going for which one? High speed option, I'll be going for medium speed option only. If I am using the same machine, 1426 CFM, or in the same option, if you are trying 1374 option, okay, this model we can try whether that is possible or not. Let me select it. The entering temperature is 27.8. 27.8 for dining area, 27.8. That will be like a 82. So coil entering DBT is 82. WBT is 19.3. 19.3. So that will come 66.74. Okay, 66.74. Even 67 is also fine. Let me select it. Which one we can select? Our to satisfy this condition, 82, 66. 1374. 80 is not there. 82 is not there. 80 is there. 66.7. 67 you can select. Okay. So 1374 CFM, single equipment, and the total coil load will come 47,733. Okay. Correct. This is selection 47,733 BTU per hour. Then how many equipments we need? 153,242 divided by this is a capacity 47733. So 153242, that is 153242 divided by 47733. 47733. We need like a 3.2 equipment, more than 3 equipments, 4 equipments we need. So when we are rounding again, it will be a problem. Airflow rate, how much it will come? 1374 CFM. 13743 CFM. Overall, how much we required? 1374 into 3 equipment minimum. If you are, for example, here you can see this is our requirement. 4894.89 divided by 1374 CFM. 1374 CFM. 1374 CFM. There also we need more than 3 equipments. So 3 to 4 equipment. 4 equipment space will be a problem there. I am planning to propose 1 equipment somewhere here. 1 equipment somewhere here. Another equipment somewhere here in the corner. 1 equipment somewhere here we can place. There is space is already congested now. So 3 equipment is more than fine. 4 is not required. So maximum equipment we can try there. 3 equipments. I am rounding that into 3 equipments instead of 4. Whether it is satisfying with respect to the manufacturer, then it will be fine. This is a maximum capacity equipment. Okay. And let me select it. 3 equipment, how much is my requirement? Plus or minus 10% allowance is fine. So this 153242 BT per hour, no, this much. I need to deliver by the help of 3 equipment. So this value divided by 3. So each equipment should satisfy this much BTU per hour. Airflow rate is this much. This is equal to 4894.89 divided by 3 equipment. Each equipment should satisfy 1631 CFM. plus or minus 10% or even sometimes 15% allowance is fine, because exactly as per the specified data, it is very difficult to get the equipment. Okay, so let me select it, and also DBT, WBT, it was 82 something, right? How much it was? Once I forgot that. 27.8, 27.8, 82. So a coil entering dry bulb temperature is 82, sorry, 82, and WBT is 19.3, 19.3, 66.74. 66.74. So which one will be the selected? See, I'm selecting medium speed, not high speed. This is a high capacity equipment with respect to this manufacturer. Beyond that, there is no other model. Okay. So medium speed, this is a medium speed option. Maximum, I'll be getting this much CFM. So CFM, I can get in medium speed is 1526 CFM. TBT 82. 82 is not there. 80 is there. WBT 66.74, 67, fine. So 115 degree Fahrenheit ambient total, I can get 58,484. So the total capacity is 58,484 BTU per hour. Okay, this is what manufacturer is providing. This is a perfect selection. Okay, and beyond that, if the requirement is high, then there is no other option. So whether that will satisfy or not, anyhow, if I am planning to propose 3 equipment, each equipment should have 51,000, but the equipment is satisfying with this one. That is fine. Slightly the capacity is more, no problem. Even if sometimes if the ambient temperature is higher than 46, we are safe. But exactly near to 51 we are getting, that is fine. But there is no other option. We can select this one. Slight higher option will come, because airflow rate should satisfy 1631. This is our requirement, but here 1526 only will come. What's the difference? 1526 divided by 1631. 1526 is what machine is delivering. Our requirement was 1631 for single equipment. 1631. If you are planning to propose 3 equipment, 4894 by 3. That is 0.93. 0.93 means 93% of airflow rate is, or 94% is satisfying. No, plus or minus 10% is fine. Airflow rate. What will happen, for example, if our requirement is 1631, but the coil airflow rate is 1526, what will happen? For example, the equipment or the software will be calculating the airflow rate with respect to this equation only. Q is equal to mCp delta T. From this equation, Q is the airflow rate, sorry, sensible coil load. Latent coil load also we can use, but the calculation will be M into H1 minus H2, or M into humidity ratio we can find out. Not H1 minus H2, M into humidity ratio difference. So equation, so airflow rate we can use either sensible or latent. M is the airflow rate in kilogram per second only. Cp is the specific heat of air 1.005. Delta T, coil leaving temperature. For example, if the coil leaving temperature is 14 and if the coil room set point is 24, this difference only. So 24 minus 14, how much it is? 10 degree is delta T. So if we need 1631, if the manufacturer is providing only 1526, mass flow rate is decreasing, means delta T will be slightly increasing there. Means the difference between the supply temperature and coil room set point will be decreasing. So means room set point remains constant in that scenario, or supply temperature may decrease. For example, instead of 14, if you are decreasing that in, means the delta T is increasing, means instead of 10 it will be decreasing into 12 and all. The coil surface temperature instead of 14, no, if the supply temperature is 14, the coil ADP remains less than 14 only. Let's say it might be like a 12.5 or 13 degrees Celsius. It will vary with respect to the bypass factor and all. That's why if the mass flow rate is decreasing, delta T will increase. Sometimes coil surface area will be also decreasing in that scenario. Then for 24 degrees Celsius, 50% relative humidity, the room ADP is 13 degrees Celsius only. But since the coil surface temperature is decreasing due to the mass flow rate reduction, delta T will increase, coil surface temperature will decrease. So instead of 13 or 12.5, sometimes the coil surface temperature will be going to 11 degrees Celsius. So if the coil ADP is decreasing, means excess condensation will happen. Because as per the room dew point, the room ADP or the room means ADP is 13. The coil ADP also should be somewhat near to 13. It should be in reality slightly less than 13 only, but excessively it is less than 13. It is coming like a 10 or 9 or 11 and all. What will happen? Excess condensation, excess dehumidification will happen. And once the room temperature is reaching to 24, relative humidity will not get 50. Sometimes it may coming 65 or 60 degrees Celsius. So that's why if the coil surface means delta airflow rate is decreasing, means delta T will increase. Sometimes return air temperature may increase, then like that also it can come. Return air temperature may increase, or coil supply temperature or ADP might be decreasing. In that scenario, excess condensation will happen. We will not be achieving the resulting relative humidity. Resulting relative humidity will be slightly high in that scenario. That's a problem, but this is very negligible difference only. No, so these kind of issues may come if the difference is higher than 20-25%. This is just okay. Okay, this is our selection. It is perfectly matching. Okay, so this is a model I am going to select. Okay, so the total coil load in our case, it may come how much? This one 58649 or sorry, this one 58484. Correct. Medium speed 58484. So 58484. There is no other option. Okay, and airflow rate will come 1526 CFM. 1526 CFM. But we need, this was one number only, but this one, no, we need 3 numbers. So the quantity will be quantity of equipment. This is 1 only, and this we need 3 numbers. Quantity in numbers. Okay. But if the 3 numbers, I have assumed 3 number, reverse also you can do. What? First you can go to this sheet, and after that you can find, as per this manufacturer, what is the maximum possible option 1526. Okay, and you can find the total coil load. Based on this you can compare. Okay, means like after selecting this 1526, then you can come to the airflow rate, how much it is, 4894. Okay, so like 4894 divided by 1526, number of equipments you need 3.2. 3.2 is not possible there. No, you can round that into 3 numbers. Coil load is also matching there. No, plus or minus 10% difference only is coming there. Okay, so this one divided by this one, slightly difference will come 3.2. We have round that into the 3.2 numbers. You can round it into 3 numbers. But in my case, what I did, I assumed 3 numbers, because since the capacity is 12 ton, the single ductable split AC, that is 99% of manufacturer will be issuing like a maximum capacity less than or equal to 5 ton only. If it is beyond 5 ton, the problem, the starting duct dimensions will be too high, bigger. No, we will not be able to accommodate that above the false ceiling. But even though ductable split unit, some manufacturers and all will be producing up to 8 ton and all, that is available in the market, but average only I told. So that's why 12.7 ton, if I am proposing two machine, it is not possible. So what minimum 3 machines I required. So assumed 3 numbers, then I have matched my equipment. That is one option. Otherwise you can do one thing, you can go to the technical data sheet, you can find the maximum possible unit. So that maximum possible unit you can compare with the our total demand. Accordingly, the number of equipments you can find, whether that is 1 or 2 or 3. Okay, both the options are permissible. That as per your requirement you can do. Now, so the model will be CHCF 060A2, CHCF 060A2, then CHEF 060A7. This is our proposed data. Based on this only, we will be doing BTU per hour divided by 12,000 ton of refrigeration, 4.8 ton only, 4 ton within the kitchen, 4.87 in the front area. Correct. This manufacturer also will be providing maximum 4 point something, less than 5 ton only it will come. 60 means like there is 5 ton equipments. 60 MBH or 60,000 BT per hour is 5 ton. A ton of, see, 1 second. Ton of refrigeration into 3.516 kilowatt MBH. BT per hour divided by 1000, that is in MBH. Airflow rate 1526 divided by 2.119, that is 720 liter per second will come. Okay. And now we can use it. Fine. Okay, so now we can proceed drafting. Means like a design with the drafting. Now the selection has done after the heat load. Now what? We have to start drafting. Before that, the equipment block I need to make. Correct. The block, because if you need to do the drafting or the designing with the drafting, now we have selected the equipment. Now we have to place the equipment. Correct. And after that, after placing the equipment, we have to select the diffusers. Air terminal selection has to be done. Duct routing has to be done. Duct sizing has to be done. Those options has to be completed, right? That's why equipment block I required. Actually, since it is, if you are making tender drawings, available block you can use within the company. Since we are making a shop drawing, actual block we required. We have not received the block, we need to make it. For example, CHCF 060 we need. CHCF 040 also we require, because within the kitchen this unit, outside the kitchen this unit. I'll be making first CHCF 048, 48. You can scroll down. Correct. These are the dimensions of, I need floor plan, this one, top view. Okay. Based on this, I will be making, in the drafting session, I have explained this one. Based on this, I will be making which one? The block. Okay. Take a snap of this one. Be taking a snipping tool. Okay. New option. I am taking this one. Okay. Now we can save this one. We can save it in a folder. And let me save it inside kitchen project. Okay, that is 048 option only. Save it. I'm saving this as JPG. Okay, this is 048. Now I'm taking CAD. Okay, a new drawing I'm taking. Unit, UN enter. Precision, let me take 00. Yeah, millimeter. Okay. Now we can attach that image. Okay, image attach. Select. We can find that within E drive, kitchen project, walking, 048, open it. Okay, keep it there. Okay, which are drawing. But this is not a scaled one. We have to scale, but since manufacturer has provided, this is scaled unit only, but the dimension is not proper here. We have to correct it. Okay, I'm just going to the dimension style. And the text height slightly I'll be modifying. Me take it 65. Okay, close it. How much dimensions we are getting for this W? Let me select from here to here. Okay, so that is property. This one is standard only, so it is coming 38133. 38133.05. But how much it should come? The actual dimension should be not this one. We have to find it. W. For 048 option, can see here, because whether that is W or if it is L or if it is D or if it is C, all the data they have provided there. So the width of that equipment in the top view, because plan we need top view only, W should come. Actually 048 and 060 is having same dimension only. There is no difference. So that is fortunate. We don't want to make two different blocks. No. So W should come 1020. 1020 millimeter. Okay. So our requirement is 1020. So our requirement is 1020. So 1020. Then the scale factor you should find divided by this value. So divided by 38133.0538. This is scale factor. Copy this one. Okay, you can Control C. Okay, since it is a scaled image provided by manufacturer, if one dimension when you are adjusting, other dimension will also get adjusted. Okay, so select this one. SC enter. Any base point you can select. Okay, and after that the scale factor you can provide there. Click enter. So now you can find the dimension is this one. Now this is a scaled one. Okay, now you can draw this one. Okay, I'll be going to a polyline and I'll be selecting a color for this one. Let me select this one. Okay, and through the surface you can draw it. Okay, so let me select a rectangle first. So through from here to here we need a rectangle, and yeah, from here to here, then until here, slightly there. Here double enter, trim that one, and there is one other polyline you can take from here to here, then here, even okay. Damage is proper. You know, it's not doing okay. Okay, example of it. Okay, that will be explaining this. So this polyline here, okay. So this other one, polyline, we can take it from here, here, here. Okay, then copy. Okay. Polyline again. Okay, here, trim this one, trim this one, trim this, trim this. Okay. Now here, delete, delete that one. Okay. Now this is also going to be this one. Okay. Okay, this one, okay. That is the answer. That's not the class. I'm going to like people like okay, polyline. Okay, no problem. This one is this one. So you can set this one, copy, this one, again. This here. Okay, anyway. Okay, this one that one. Then we make this again. Polyline, you can make this here, 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 here. Okay, here, fine. Then that's all we can. This one and this one. Polyline. Okay. This one should be approximated. Make it. This one. This one. This one. Okay, so one certain calculations we can make. Polyline. Here, okay. Anything else? Nothing. Select this one. Delete it. So this is my block. Save this. Okay, I'm saving this as a W block so that in all the projects I can use WB. And okay, fine. Save this. Select object, enter. Save this inside the folder that we are working. Like, let's say a folder I'm creating like W block. CF48. CF 048 unit. Okay, and the same block we can use for our designing with the drafting. This we will be continuing with the next session. Okay,